right. Well, thank you everyone for being here for this September sustainability series. We're very excited to welcome Tim Ian to talk about Passive House, the economic and environmental solution for a sustainable future. Tim works in Minnesota and was introduced to us from a community member, so we're really excited to host him today and learn from him. Just a couple of quick housekeeping items. If you could type any questions that you have as Tim's working through his presentation in the chat, that would be helpful. We will have a good amount of time for questions at the end as well, and I'll try to find a natural pause in the presentation for questions that are pertinent to the slides in real time. We will also share a recording and the slide deck from today, so don't feel like you have to furiously write notes because we'll share this material after the fact. Otherwise, very thankful for everyone being here today and excited to learn from Tim. So Tim, I'll turn it over to you and get out of the way. Thanks for being here.
Thank you. Thank you so much for having me. I'm super excited. I'm going to talk a little bit about buildings, about Passive House today, and I'm happy to take your questions afterwards, as Kevin pointed out. You may at times feel a little bit like you're getting information from a fire hose. I apologize if you don't know what a passive house is. There may be some deep dive stuff that we don't have a lot of time to get into, but I want to give you sort of a broad overview of what this means and why it is important to us here in the state as a country and for the world of buildings as a whole. So I'll lead in with, why are we even talking about buildings? And a couple of points to note here is, they're very important to us, but yet they're often failing us. We spend a lot of our time indoors. Buildings account for 40% of global emissions. And yet with the importance that they have and the footprint that they have, they're often unreliable, expensive, and they can even make people sick. So arguably, we haven't quite arrived with our codes and ordinances, and we can do better. So let's for a moment then just imagine the perfect building. It could be your home, your school, workplace, a place for entertainment. How would you describe it? It's a question that I ask clients, that I ask when I go out in public. And here are some of the highlights of what I typically hear. In a cold climate like Minnesota, people definitely want to be warm in the winter inside of a building. But also with the climate shifting a little bit, they are more and more concerned with staying cool in the summer. Nobody likes drafty buildings. There's also noise associated with that. And more people are talking about wanting low energy bills and little to no fossil fuel use. So they don't want to be part of the problem, they want to be part of the solution. Buildings should generally be affordable to build and operate. I want to stress that second part. Most of you, hopefully, will understand that building a building or buying a building, while a big expense, is really only part of a larger picture, and that buildings really cost over time, and that's something that we're concerned with as well. And a really good building should be healthy and free from smoke, soot, pollen, mold, and bugs. Again, these things go without saying, perhaps, but in reality, we've all seen buildings that wouldn't really live up to those standards. Smoke has become a real issue in recent years here in the United States, so it's something that want to think about. And then coming from an extreme climate zone like Minnesota, we want to make sure that we have a good shelter that can perhaps weather the storm, do a few days without needing energy or infrastructure. And keep people safe. And so that's another big consideration, especially with the climate again shifting. We want buildings to be quiet, even if you're living on a busy street near a transit hub or a noisy business. And last but not least, we want them to be peaceful. We want them to be sanctuaries. These are places that we retreat to. And so we want to be able to have a peaceful environment that we can enjoy. And the good news that I have for you is that all of this is real. And has been for a while. When you look at the passive house in Kranichstein, that's the very first passive house that has ever been constructed and certified. Darmstadt, Germany, 1991. So for the last 31 years, we've had a building standard that aims to deliver all of these points that I just made to you. And I'll show you today how that works. So let's start with the textbook definition. What even is a passive house? You can see there the original German name up on the left and then the translation. Well, first and foremost, it is a rigorous voluntary building energy standard that focuses on the highest energy efficiency and quality of life at low operating cost. So in this sentence here, you already have sort of the answer to some of the requests for what we want really good buildings to deliver. Also in this slide, you can see there's a couple of different logos here. It comes in different flavors. We might talk about that some more today, maybe not, but there's sort of a good, better, best approach that's being taken here. There are similarities, there are some differences, and this also applies to retrofits very importantly, because so many of the buildings we will continue to have, and we may want to improve. Passive house is a global standard. The idea behind that is to think globally, but build locally, and it is climate zone specific. So there are targets and metrics and tools that apply depending on where you are on the planet. Arguably, it gets pretty exciting here. I've been practicing passive house for over 15 years here in Minnesota, and our climate has a little of each, right? Hot and humid and dry and cold. And so for passive house nerds, this is a cool place to be just because we have sort of both extreme ends that we need to design to. As I quickly pointed out, passive house applies to all building types, and I'll give you some global examples here to kind of create the sort of the breadth of it. The first one just completed this year is the General Hospital in Frankfurt, Germany. That is all fully passive house certified. And to my knowledge, was the first general hospital, large scale hospital that adhered to the passive house standard and was built to it. Another healthcare building from Spain. This is just a healthcare center, a regional healthcare center in Spain. So completely different climate zone, but again, I want to give you a little bit of the flavor. A large project currently ongoing here in the United States, Sendero Verde in New York City, 720 living units from memory and some mixed use components. So very large scale passive houses, also a possibility. And also currently ongoing, the tallest, designated as probably the tallest passive house in the world, the Curve Tower in Vancouver, British Columbia. Here's an elementary school in Germany that was certified many years ago. The Carrick Library, a public building in Pittsburgh, Pennsylvania. And kind of to round out the conversation here, a museum, the Passive House Pavilion in Longfor Sanda in China, has been operating for a few years, and it's really cool because it houses also a permanent passive house exhibit. Passive house is a third-party certified standard. We'll talk about standards a little bit today as well, so you get a little bit of a comparison with other programs out there. You don't have to certify a passive house, but you can. And you can also get certified as a professional to practice in the passive house realm. It's also a vetted tool for sustainable design, and that's a unique selling point for Passive House because there are tools that come with this program for architects, for engineers, for consultants that are very, very helpful to illustrate building performance as you're designing. And that's not something that can be said for all building standards, voluntary building standards. So this is actually a hands-on type thing, and one of the reasons why I personally gravitated towards it all those years ago. There are, as I mentioned earlier, a few different pathways to achieving Passive House, and so they happen at slightly different levels of performance. They also bank on varying levels of renewables. The main thing to note here is that you cannot renewable your way out of the Passive House standard, meaning you cannot make up for building shortcomings with PV panels or offsite renewables, but you can count them once you make a passive house, and you can sort of achieve a different tier of certification doing that. And again, it applies to all building types, residential, commercial, retrofits, and new construction. And so these tiers can then also be applied to the varying building types. And really, it revolves around one basic concept. It's energy conservation first. So we get rid of wasteful energy use, everything that isn't necessary to provide the services that we seek. We try to minimize as much as we can. by minimizing losses and then maximize free gains. And the picture that I'm giving you here is one of my house, just because it makes a point. To the left in that image, you could see my solar facade. So the glass there is harvesting free warmth in the Minnesota winter. And so the building is super insulated, airtight. We'll get into that in a minute, but we're also harvesting free energy that's available to heat it. So that's the lead in. 5 basic principles from the lower left all the way to the lower right. We have thermal insulation. Now, code stipulates already that you want to insulate a building in Minnesota, obviously, but passive houses will be much, much better insulated. Generally, you can expect 2 to 3 times code levels of insulation in all assemblies, and we want it to be continuous. And then we combine that with what we call passive house windows. These are carefully selected and put together, high performance frame, good spacer, usually triple pane for a cold and extreme climate like ours. So these will be airtight. They will allow solar heat gains when desirable for the building to bring free heat in and then lock it in with coatings. So they're just a little bit more special than your average window, and they become an active part of the strategy. So think of the building as a thermal battery, and the passive house windows can become the charger for that in the winter. In the summer, it's quite the opposite, and we look at shading them properly. We want an adequate ventilation strategy at the top. So a passive house, that's the next point already, will also be airtight. And when you make an airtight enclosure, you also need to worry about or be concerned with the quality of the indoor air. So we'll have active ventilation in all passive house buildings with a heat recovery ventilator. That ensures that in the winter, the incoming air is pre-warmed with the stale outgoing air, and in the summer, it's pre-cooled. And airtightness is important because leakage in buildings can account for a quarter, sometimes more, of all the energy transfer to the environment. And that's something we don't want. So we want to shut that off. The last point on the lower right-hand corner is a little bit more obscure, maybe for most. It's something called thermal bridge reduction. And a thermal bridge, the best way to describe this to a layperson in Minnesota, perhaps, is if you rip the sleeve off of your winter coat in the winter and off your shirt and off your sweater, and you let your bare arms sort of dangling out in the winter, you know, it'll get cold, obviously, and that cold will creep in through your arm, through your flesh and your bones, and you'll get cold as a result of that. And the same thing is true for buildings, you know, with attachment points. Often we have decks or balconies or things like that that simply reach outside of the insulated building envelope and are not disconnected from it, and now we create sort of an inverted radiator. We inadvertently either leak warmth in the winter to the exterior, or we pick up warmth in the summer when we don't want it. This is mostly a design exercise, so we want to build thermal bridge free. You may also wonder how it got its funny name. Active versus passive is really the sort of the reason why. So if you consider the buildings of the past as active buildings, you have a building envelope with little to no insulation. It's not very airtight. We're illustrating that here on your left with that window sort of tipped in there. There's imperfections. Now we need a large active mechanical system to provide heating, cooling, those types of services to overcome what the building envelope can't do on its own. Well, in the passive landscape, we're banking on energy retention and free heat gains. So we really maximize what the building envelope will do, and thereby we can really minimize what active componentry we have to put into a passive house. And that's really where it gets its name. It banks on passive mechanisms, and it's not so reliant on active mechanisms. I'm giving you some numbers down below. Generally, energy is tracked in some kind of energy number per square foot in year. In this case here, the kBTUs, and you can see we're order of magnitudes smaller when it comes to heating energy, and more on that in a minute. So passive house is a real paradigm shift. So if you consider existing buildings and buildings of the past to be synonymous with that tent with the stove in it on the left, you know, it's leaky, drafty, not very well insulated. We have a massive heating system inside of it to keep it comfortable. From there, we're really leaping, and I'm using, you know, metaphorically here, the cooler box as a super insulated envelope, the thermos bottle to illustrate that we're making it airtight. And when you do those things in combo, you can heat it essentially with a candle. So just kind of run with that in your mind right now. Those are the main improvements we're making over the status quo to enable performance. And a few years back, I did a study for the University of Minnesota, and we compared a single family home and its energy usage and footprint between a code building and a passive house. It was the same building, designed exactly the same way. One built to Minnesota code, the other one as a passive house, and the result is what you see in the slide, the pie chart here. So you can see code buildings consume mostly heating energy in Minnesota, a very significant component, and that in a passive house is massively shrunk. These pie charts are to scale. So overall, I find in a residential setting, to use that as an example, 50 to 75% less total energy use, with the heating energy component seeing the most drastic of reductions. In some cases, over 90% less heating energy is used when the building shell is built properly. And the way that this is tracked, again, is energy per square foot in years. So we establish a gas mileage for buildings, and that's both in our energy modeling and in the real world, you can measure these numbers. And there are some targets. There won't be a quiz here today. You don't have to memorize these, but some of you in the audience, this may be meaningful to you. And as I mentioned before, there's slightly different tiers. So there's an entry-level certification called low energy building. There's the retrofit component called EnerFit, and then there's the new construction standard. And in order, they get a little bit more stringent. And you may ask yourself, why do we do that? Well, in existing buildings, the middle tier here, it can be hard to right every wrong, so that you can use a little bit more energy in a retrofit building. And the low energy building standard came out of a desire to be able to certify buildings that maybe have a few strikes against them, even though they're new, meaning either the use or the location don't enable them to meet all the new construction criteria. And so there's an entry level and on-ramp certification that, to be honest, is still a huge leap over code and therefore quite interesting. There's also source energy targets. Now, source energy is when you track the energy that a building consumes all the way back to where it is made, a power plant, for instance. And the reason why that's being tracked is because that's generally where the pollution happens, where the extraction of energy happens. So we got to make sure we keep a lid on that. And last but not least, here we have a suggested heat load target, and that is something that's difficult to do in Minnesota, but works quite well in more moderate climate zones. When you stay below the metrics here, you can actually heat and cool the building through the ventilation system alone and do away with active heating and cooling systems altogether, which is quite nice, but doesn't work in Minnesota with our current climate data. Air tightness, I mentioned it before, is a key component here, is also being managed and tracked, and 0.6 air changes at 50 pascals pressure is the target for new construction, and that has been readily achieved for the last 15 years or so since we've had passive house in the United States. Code, for comparison, is 3 air changes at 50 pascals for a residential building, so a passive house is 5 times tighter. And when you do retrofits, you do have some component targets. So sometimes when you can't get the entire building to perform at a certain level, you can also upgrade individual components to specified levels and do it that way. And that can also be very attractive. All passive house buildings are energy modeled in a program called the PHPP, the Passive House Planning Package, which has been vetted the world over by different organizations, including ASHRAE, and found to be very accurate and helpful. And this is the ultimate way to value engineer a building, because concurrently with design, the PHPP will tell you how your building is performing, and you can now be much smarter about selecting windows or glass or insulation. So just a couple of bullet points here. Principles and metrics apply to all building types anywhere in the world. They're universal, just based on sheer building science. There's no real sort of, how should we say, there's nobody who benefits or profits off the standard itself. So there's no agenda in the background. We're really just using pure metrics to deliver a sustainable carbon footprint and superior human comfort, well-being, and optimized life cycle cost. They're not arbitrary. They're based on these things that I told you that we would like to achieve in buildings. And they're absolute targets with measurable results. Passive House has been around since 1991, as I pointed out. So there's been many studies to validate the standard. It's a foundation for climate neutrality in the built environment, and therefore has been endorsed by the UN as the solution for the sustainable future of buildings. I won't read out all of this here. I just want to give you an idea of delivery and certification. Passive houses are ideally delivered by a team of people who have a little bit of history and maybe some education with it. That'll be the most effective way. And while you don't have to certify a passive house and people doing one don't have to be certified, there's definitely some benefits to that. And maybe that's something we'll talk more about today. Passive house has a very clear focus. It doesn't really compete with other programs like LEED, for instance. It focuses on energy and thereby directly affects your building envelope, mechanical systems, maybe electrical systems, and renewable energy systems. There are indirect components that are affected: water systems, stormwater, building materials, and embodied energy and carbon. And again, this may be something where we go a little deeper later. I just want you to know it has a sort of laser sharp focus on operational energy first and foremost, and other things are sort of indirect benefits that come with it. The low life cycle cost can be explained with the help of this graph here a little bit better. If you look at it, what you're seeing here is an investment in a component of a building and how long that is useful. So on the bottom, when you look at structure, you can see 100 years. So the structure of a building, unless it takes damage from water or fire, that'll go the full distance, right? The building envelope, when constructed properly, also can have fairly long and drawn out maintenance cycles, 50 years perhaps. But then when we get to HVAC, that may only be 25 years, and with today's tech, sometimes less than that, and then finishes, of course, wear much quicker. And so what happens with the passive house is you're taking investment from a mechanical strategy and dumping it into the building envelope, and thereby every dollar you spend here will go twice or maybe 3 or 4 times the distance. And so it is a smarter investment over time and pays you back. So with that, passive house defines the long-term building quality and performance independent of energy supply. It reduces the amount of useful energy needed to own and operate a building significantly. So that's sort of my first step here in bringing you what passive house is. Let me show you some examples that are local to us. The Glazing Biohaus, 2006, Bemidji, Minnesota, officially the first certified passive house in the United States, actually on the continent. And then just a couple of years later, Passive House in the Woods, a project we did in Wisconsin, became the first certified passive house on the other side of the border. Minifit House, one of the first cold climate retrofits to passive house standard in the world, was a pilot project in 2012. A project that started out as certified passive house became a FIA certified multifamily affordable housing project here in Minneapolis, Hook and Ladder from 2016. And a project that again started out as a passive house retrofit in this case for public housing, Elliott Towers, later got done a little differently, but these are some of the landmarks that we have. Lexington Parkway Passive House, Minnesota's first passive house plus with a significant renewable energy component. Can't see it, it's hiding on the roof. And then the same thing here for Minneapolis in this example. Last but not least, Bright House completed this year the first affordable housing project in the state done to the passive house building energy standard. So let me get into why passive house targets. Well, to understand that, I'll give you this chart. When you're inside of a building, you're looking at the right-hand column here. You're experiencing what we would call useful energy, things to satisfy our needs: hot water, heat, fresh air, light. Well, to get to that, you pay at the meter, which is in the middle, but it's really made on the left-hand side, what we call source energy. So that's where extraction, production, pollution happens. So every bit of energy that you can save on the right-hand chart of the site, you also save lots of energy on the left-hand side. And that's mostly because there's loss factors and other things. So there's kind of a thing spinning up. When you save on the right, you save even more on the left. I'm going to skip over that for the interest of time. We can come back to that. So when we look at climate change scenarios that we have on the books right now from the IPCC here, you can see that, we're not very aggressive with that at the moment. So pollution, and I would call CO2 pollution, is what happens as source energy. So why are we managing that? Well, because of these graphs here. We got to get out of the game of fossil fuels. And so by using our useful energy more smartly, we can reduce source energy and maybe have a better chance at meeting some of these scenarios that are laid out here. The pledges that we have in most parts of the world are fairly insufficient. We're not really looking all that great at the moment. And the reason why I say that is I don't want to create doomsday scenario, but I want to give you the impression we have tools like Passive House that can leapfrog, that can help us make things like that look a lot better. And with that, we can sort of win our own climate Olympics. Right now, we average about 20 tons of CO2 per capita per year. And to get to where climate scientists tell us we need to be, we really need to bring that down to 1. So that gives you an order of magnitude here of what we're facing. So when you bring that back to a residential home, for instance, and the energy that is used there, we have sort of 2 ways that we can do it. We can either try to substitute the footprint that a building has with all clean energy here on the left. So we have to make a significant amount of clean energy, much more we're making today. And then the other option we have is we simply come up with efficiency and sufficiency measures so that we don't need that much energy anymore. And you can see we have a much better shot at using a green grid wisely and making that go the distance. So in Minnesota today, again, we have these aspirations. We have a standard that was introduced here for 100% clean electricity by mid-century. When you look at, this is a graph for Minneapolis, how all energy in Minneapolis is used. When you look at the gray mountain in the background, you can see we use mostly heating energy, much more than we do for driving and lighting and other things like that. And that's really the mountain we need to conquer. So our clean energy plan of business as usual plus electrify everything leaves us with a very, very significant hill. So I call that we have a hill and valley problem. We can't make renewables in the winter very well. And so we don't know how to get on top of that. So again, we need to be a little smarter and come up with a carbon framework plan that leverages efficiency plus sufficiency and then modulates the renewables. Here's a study that we did for the city of Vancouver that shows how that's done. You reduce the energy footprint first, and then you come up with fossil-free energy production to get on top of it. And then Vancouver, in turn, decided for buildings, they're going to turn this into a multi-step program, a 5-step program from now until 2032. And this program is currently active. And the way that they're telling building designers to do it is with Passive House. This is officially from the city of Vancouver's website, and you can see that spelled out right there. And again, the reason why we do it, useful energy has a loss factor to source energy where the pollution happens. So wasting energy inside of the building means we have a lot more source energy we need to make. It's compounding. On the flip side, if we build a passive house and we're very mindful and use energy sparingly in the building, saving energy here really spins up multiplied savings on the source energy side. And mapping that out for the city of Minneapolis, you can see if we retrofit buildings to passive house and build new to passive house, remember that mountain in the background, I kept it in here, it's gone. We can reduce it so much that we can almost meet the entire demand with our current electric infrastructure. So a passive house strategy works and can help us meet our carbon goals and climate goals and green grid goals that we currently have. RMI found the same thing. They came out with a outline here called decarbonizing homes, and the term that they coined beneficial electrification. I won't have time to get into the details with that, but you can do a deeper dive there and see why what I'm telling you today can be done with passive house. And then, by the way, we can also reduce embodied energy. And one of the benefits of the passive house planning package energy model is that it also offers a thing called the pH ribbon, which is a carbon counter. So you can see what building materials you're using and how they're affecting that. And you can be smart about doing this in a way that doesn't additionally burden us with climate footprint. So in sum, efficiency first, paired with renewables is really the foundation for meaningful climate action. And in a passive house, we multiply then these benefits of that strategy with human comfort, resiliency, durability, life cycle cost efficiency. And there's also a social justice component, again, a piece that we could do a whole nother talk about, but that's the benefit of passive house. So it transforms the status quo. All right, I'll leap into a couple more things here. For those who are in the building sector, I want to give you just a quick idea of how it compares and fits in with other programs. So generally, it plays very nicely with what we have. You see a lot of the logos down below of the programs that you know and may use right now: Architecture 2030, Living, Building challenge, enterprise, green communities, LEED, and so on and so forth. And so with its focus on energy and comfort and life cycle cost, it doesn't really compete with any of them. It plugs in very nicely. With code, we exceed all the minimums with a passive house, so there's really no competition. We just make buildings much, much better. And actually, passive house has become code in some jurisdictions around the globe, not in Minnesota at the moment, but in other places. When we look at ASHRAE is intrigued by passive house and actually currently has a working group that's looking to perhaps create their own or adopt the passive building standards that are in the market. So they're also looking at it. LEED has a program that recognizes passive house for full points in the energy component. So if you do a passive house, you qualify for full credits for energy. The Living Building Challenge has also a crosswalk. So again, here for their zero energy certification, you can use the passive house certificate, so that plugs in readily. Enterprise Green Communities in Minnesota gives you extra points, and it looks like that may be spelled out even more explicitly going forward. Minneapolis came out with a sustainable homes policy in 2020, $5 million, up to 20% of cost or $90,000 per unit for affordable housing units built to the passive house standard. Energy Star, again, there's no competition here. You're meeting the spirit of a program like that quicker, and you're just doing much, much better. And the local program, B3, SB 2030, and Architecture 2030, that's very similar, you know, is very encouraging of it. And again, if you take a passive house, you can readily plug that into those programs and meet their targets. We could talk more about that. The CSBR here at the U of M has endorsed the program. Architecture 2030 spells it out just shy of naming passive house, but when they talk about their goals, they say energy efficient design strategy, proper orientation, daylighting, passive heating and cooling. So, I mean, you can put two and two together. What they're describing there is a passive house. So the key findings, just a couple more things here in the minutes that I have that I can give you as a practitioner here in Minnesota. When we go for passive house, the differences in construction and systems are manageable. They require some diligence, and it's good if you have somebody on your team who has experience, particularly for the design and energy model. That's a good idea. But it can be done even with people who are still learning on the job. It costs differently on day one due to the investment in sustainability, and it costs differently over time as well. So most of you will ask yourself, well, how much more does this cost? It's the number one question I always get. And the answer to that is it doesn't really cost more, it costs differently. You invest like you would in a solar panel in a better shell, and that shell pays you back for the life of the building. So ultimately, it's the cheapest building you can own and operate. But on day one, you know, we see cost anywhere from 0 to 10, maybe 12% more. And this has a lot to do with who does it. Is it the first time doing it, and other things like that. But we've also seen in some markets that between comparable projects, it doesn't cost more at all, that sometimes the market differences of who does a project are actually greater than you know, making a building a passive house. So take all this with a grain of salt. The life cycle costs are cheaper. We don't have time to give you case studies today, but we've conducted a bunch of them. And so that's even before anybody puts a cost or value on human benefits like comfort or health or anything like that. The energy performance is entirely different, as I showed you. Heating is no longer a major consumer of energy. And so we can focus on other consumers of energy. And also, because heating is not really a challenge anymore, we don't have to worry about it. So if the power goes out in the dead of winter, fine. The building isn't going to freeze. Nobody's going to die. So it gives us that resilience. So thereby, I would say passive house fits the paradigm of sustainable building that we're all talking about. And maybe last but not least, the learning curve that so many perceive that is in the market is so quickly eliminated. Having done this now for 15 years here with regularity, you know, once you get your feet under you, it's really not a big deal, or not as big of a deal as many people think from the outset. All right, so I got 4 more minutes to the comments here. So I want to leave you with a couple of things that you can do. Because that's also a question I often get, and I want to leave people encouraged and going out there, you know, telling others about what they learned. So the first thing is actively think about and consider passive house. You've now heard about it, you've learned a little bit about it, you know, look it up, do a deeper dive. And when you come across a project, when you talk to stakeholders, no matter what your role in it, float that term, see if people have heard about it or if they're open to considering it. Renovate your own house or other buildings and build to Passive House standard. This is really something that solves a lot of problems for us individually, financially, on a global scale. So look at it that way. And for those of you who are in decision-making positions, require it. Simply ask your teams to deliver Passive House projects for public buildings, private developments, doesn't really matter. Many places around the world do already, and that list is only ever growing. And then for yourself, consider getting Passive House trained or certified. I'm also here today as a representative of the Passive House Network, which is our North American organization. You can get certified, your building can get certified, and materials and products that you make, components that you make, can also get certified under this program. And here's just a few resources that I can leave you with today. So we have our stakeholder organization, the Passive House Institute, who is sort of the curator of the standard. But again, there's really no monetary gain here. This is not a for-profit endeavor. This is more of an educational setting where this is coming from. We have our global user organization, International Passive House Association, that puts on global events like this November. We have, again, open days, which happens twice a year all over the planet, where people share their passive houses and you can go and tour them. There's always one open here in Minnesota somewhere. And then we have our North American organization, the Passive House Network. You can see it right there in the middle. Passive House Minnesota, which I'm the founding member of here locally in the state. For those who really want to do a deeper dive and read about it, there's Passipedia. It's a wiki that is geared entirely to Passive House. And then in North America, we also have an extremely vibrant community of great practitioners who are happy to share their knowledge. And a lot of that happens on a page called Passive House Accelerator, which puts on weekly webinars and has a massive YouTube channel. So I can encourage all of you to look for these things. So with that, I'll turn off the fire hose. I thank you for your time. My organization is T Studio. I design mostly residential Passive House buildings. Passive House Minnesota is our local chapter. The Passive House Network, our national organization. And I appreciate your time and I look forward to your questions.
Awesome, thanks, Tim. Yeah, open it up for open Q&A from anyone in the chat here. Otherwise, I got a couple questions too. Any questions from the group? Tim, I'm curious on your perspective on some of the federal programs, Inflation Reduction Act and other policy kind of decisions made at a federal level, and how you see they might impact the proliferation of Passive House, or can you help the audience, I guess, understand, is there any overlap between Inflation Reduction Act and some of the things that it's offering upfront discounts or tax credits for compared to the Passive House certification or performance that we just heard about?
Sure. Yeah, no, absolutely. And there are, of course, because what's targeted here is energy reduction in buildings, and there's money behind it. All the funding has been increased over what it has been in the past. It's not massive amounts of money, but if you make a passive house, you will, again, overqualify for many of them. So the benefits that you have for being able to do a heat pump, insulation, windows, you'll be able to claim all of those. And of course, that program has different avenues depending on whether you're dealing with a residential project or affordable housing or something like that. So short of going into those specifics, absolutely, will you qualify for those? And people have in the past too, to be honest. Most of them are still tied to a HERS rating, especially in the residential realm, and that's fine. Passive House will massively excel with a very good HERS rating, but the Passive House Network is also working on an effort to try to get governmental agencies to recognize it as sort of a checkbox. Simply because it eclipses so many of the low-hanging fruit programs that are out there. And rather than making you, the owner or developer, jump through a bunch of hoops, we are trying to lobby a little bit harder for being able to sort of get a Passive House check mark that simply enables the qualification. And you could say that for many things. That's true for appraisals. real estate that is bought and sold. So there's also an effort here in Minnesota. Again, there was another one many years ago that failed, but there's renewed interest in getting building standards on the MLS so that realtors know what they're selling, buyers know what they're buying. And so I can tell you, yes, with the federal policy and local policies and efforts, this is constantly getting better right now. And more organizations are starting to recognize Passive House out of the gate. Where they don't, again, then a HERS rating, which will be very good for a Passive House, can act as a stand-in, for instance. Yep.
Awesome. Thanks, Tim. Other questions from listeners still here? Yes, some kudos.
I answered them all.
Well, I do have one question. Sorry, because this presentation was just excellent. I was just wondering, have you seen an increase in the number of people who are building with this technique or this philosophy or these products?
Yes. Yeah, we have. And, we're probably in North America, we're still in, what the tech companies would sort of refer to as their startup stage, where, if you compare this to maybe a Tesla right now, where they simply can't make the electric cars as fast as people are ordering them, the Passive House community in the last 2-3 years has experienced basically the same thing. So at this moment in time, there's probably not enough practitioners in the market to deliver all the Passive House projects that are being put forth. And so I would say there's a massive uptick. Regionally, it will vary greatly. It's a big country. We have different attitudes towards environmentalism, resiliency, the value of real estate, and all of that. So you're going to see that in some markets more expressed than in others. But I can tell you, if you want to see some of the places where it's really taken off, Massachusetts, Pennsylvania, New York, BC, British Columbia, of course, the Pacific Northwest as a whole, with the, let's say, greater Seattle and Portland areas maybe leading that. But even, in much more obscure places, like the Rocky Mountains, for instance. So you may know that last year we had a sort of a massive brush fire in the greater Boulder area that took out an entire subdivision there. And Excel Energy actually put out a program where they give you massive incentives if you build back using the Passive House standard. And so there were a few dozen homes left right now, and I forget exactly how many, but it maybe not 100, but again, tens of projects. And as people are looking at building back right now, from what I understand, 80% of those considering to build are looking to do it with Passive House. And so again, you go to a place like that, you see it in a bubble. You go to New York, where they have real policy around it, not just for new, but also retrofitting with it in the future. Those are kind of hotbeds then, and those are all sparks from which this flame is sort of fanned. Yeah.
Thank you. Just one more question, I'm sorry, but as far as the education of architects, is this part of the curriculum? I mean, is this?
No, we all wish it were, and it was, or in some markets. So my background is perhaps unique in that I grew up in Germany and I went through architecture school there and graduated with an engineer's title. And so I actually learned about this in the 90s when I was in school. But my understanding is that most architecture programs, especially here in North America, don't have a building science component at all. So that's a challenge that we have in the market, and that's why we offer educational programs for architects, engineers, and the like, because we can't bank on that. It doesn't exist, so we have to create it, and we've done that successfully over the years. So that's a very robust program. That's probably also in its like 13th year or whatever of being rolled out here. And with COVID, a lot of this became available online. So it's readily out there. There's classes in person. We do this for contractors as well. There's a hands-on class and certification that they can get. That's maybe better personally attended, but especially for architects and engineers, there's a week-long class that they can take online to earn this qualification.
Okay, thank you very much.
Mm-hmm. Yep, absolutely.
Great, thank you. Any other questions from the group? We have one hand raised. Go ahead, Christine.
Thanks, Kevin. Tim, thank you very much. I have a general question. Passive house glazing is critical. And glazing, as I understand it, you know, in terms of its durability of performance, in terms of heat gain and how it controls it, we're still pretty limited in our technology and our durability. I mean, people talk about modern windows being 15-year durability. Can you comment on this or give some
Sure,
advice?
I'll try at least.
10 years?
Yeah. Yeah, I could try at least. I would say the durability of the glass is probably not really the challenge as much as maybe the edging around where the glass panes are being held together. And then the frame that it goes into.
Insert, et cetera, that people keep talking about. The
Yes,
glass
and it's a cheaply made product. So that's another issue. A passive house is a quality building because it needs to, you know, hold itself up to higher standards. And so we typically end up using you know, much higher grade product there. And the useful life of that is actually it can be quite durable. It wouldn't be unreasonable to think that you can get that glazing to perform 25 to 40 years. And there's some data to suggest that that's true. But the market here, especially the residential market, is and has been, I've been practicing here well over 20 years. It's sort of a race for the bottom dollar. So everything has to be inexpensively made and the quality, the bar is just really low. And I think that's maybe what you're seeing. So for us, that's not really so much of a concern. The cold climate passive house windows that we use in our projects are built like tanks, and we typically don't see any short-term failures with them or performance waning over time. They're also serviceable. They tend to be much beefier frames with beefier hardware, more layers of gaskets and parts that you could exchange and repair, short of throwing a window in a dumpster and starting over. And so from that perspective, the market really isn't waiting for anything else to come out or to improve massively. I designed my first passive house here in 2008. That building's been owned and operated since then, so coming up on 15 years, and we haven't seen any problems with it. Actually, the bio house, my business partner who's now retired, designed that in 2005. It was built in 2006. The only window failure we had there is that's a school building on a campus, and a student put a piece of furniture through a pane of glass, I think, or something like that. So this can happen anywhere. This had nothing to do with the quality of the product. So from all angles, that's not really a concern that we have at the moment.
Okay, so I'm going to ask you just for some examples of manufacturers that meet your standards.
Sure. You want brand names? Is that what you're looking for?
Within the United States, in terms of good producers, and again, it's a matter of distance and how far it travels and everything. Yeah, I'd like some examples.
So there's an outfit in Kansas that makes a passive house certified window. There's a number of outfits in Canada that do. All other product is either imported or it is assembled from imported source materials. And just to put that in perspective, I think I know where you're going with that. That's actually true for just about anything you stuff in a building these days. So we got to be careful how we talk about that. There's nothing particularly evil or exotic about that process in general. The usual players here, like your Marvin, Pella, Anderson, may offer a moderate climate passive house window because they don't make anything specific for cold climate, but for us here locally, they don't at the moment. And I think technically they could make a product like that, but the market, the perceived market, is too small where they simply haven't bothered yet. We had a window symposium earlier in the year where somebody floated some numbers. I think, nationwide, the market for windows is tens, if not low hundreds of millions of units a year, where passive house windows, currently maybe a few 100,000. And that's really what that is a chicken and egg thing. And so if you want to be able to buy a passive house window at Home Depot, we got to get to these numbers before it's being manufactured here and sold in that way. And until then, it comes from a few select places, imported whole or imported components that are assembled in North America. And those are the choices we have.
Tim, thank you very much.
Yeah. All good. And it's important to get a good window in a passive house. It doesn't really work if you don't have that. There was a commercial some years ago where somebody brought a faucet to an architect for Moen or Delta or something, and they said, "Can you build me a house around that?" And they meant the style of the faucet or whatever. And in passive house design, we could take the window and say, "Can you build me a house around that?" And I think that's a pretty good metaphor for the quality of the building itself. I'd love to show you one. I'm surrounded by passive house windows. There's one behind me and one next to me, but I'm sure it's not really going to do it justice as a tilt and turn window right here. But I could tell you, if you find an opportunity to go visit a passive house, do that, play with them, and you'll see what I mean. It's just a completely different league of performance. They feel differently. They're very quiet and extremely comfortable.
Thank you.
Yeah. Any other questions for Tim? I guess I just have one curiosity. Tim, you mentioned living in a passive house. Just curious, like what your utility bills are on an annual basis, if you don't mind sharing or something.
No, I don't at all. So I have also solar panels on my roof. So that doesn't tell you all that much. Generally speaking, right now, I don't have any utility bill because what I make in any given year and what I consume equals just about. And then there's still the Minnesota incentive program, which goes for 10 years. So they give me a little extra over the top. So at present, I don't have a utility bill. But my house, family of 4, COVID times, I work from home. My wife works from home. My kids were schooled from home until last year. Obviously, now they go back. But in the first year here, this has only been around for a couple of years. We consumed about 12,000 kilowatt hours for an entire year. So about 1,000 kilowatt hours a month in this building. And again, any and all of that was also produced on the roof, but not at the same time. And so there's this back and forth of sometimes I pay a little and then I get a check back. So that complicates this to some extent. But what's beautiful about passive house on a residential scale in Minnesota is that you can actually create a full offset on your own roof, which really wouldn't work with anything but a passive house because your heating load would be too great. And the other thing I can tell you is it's all electric. There is no gas here. We don't need that for anything. It's all heat pump based with electricity. So we get our electricity either off our own roof or we're 100% wind power on the supply. So when it doesn't come off the roof, it comes from wind generated electricity. And so this is that carrot. We have full carbon neutrality for this building for its operation.
It's awesome. Thanks for that detail. Really, really impressive. Any final questions for Tim? All right, hearing none. Tim, really appreciate you being here and spending an hour with us. This was really informative, and based on the questions too, you can see there's some interest in the community about learning more, and hopefully we'll get our first one in Rochester soon too.
Yeah, that sounds good. I look forward to it. Thank you for having me today. And again, you're welcome to share the slides and the resources. And we could also build on this in the future if there's continued interest or people want to go down individuals or the rabbit holes of things. Yeah.
That'd be awesome. Yeah, let's talk more about that.
Okay.
Cool. Well, everyone have a good day, and we'll see you next month for the next series. And thanks once again, Tim. This was great.
Thank you.
Thanks.
Bye-bye.